This video is provided by Welcome to Electrochemistry. Sorry about that. You.
Me?
Yes, you. I'm going to ask you a question. Do you know the Nernst equation?
No.
Okay, I will tell you a story. Once upon a time, there were scientists who were proud of themselves for their inventions and discoveries of the galvanic cell and how they were able to calculate the potential cell in the standard conditions until one of them asked a question.
How can we calculate the potential cell if it was not in the standard condition?
Until there was a hero who was able to solve the big problem, and it's now known by his name, the Nernst equation. And the sign...
What about these weird signs?
This is what I was going to explain. E is the potential cell, and that's what we want to calculate. The unit will be in volt. E naught is the cell potential under the standard conditions. The unit will be in volt. R is the ideal gas constant, and the value is equal to 8.3145 joule per mole times Kelvin. T is the temperature in Kelvin. N is the number of electrons in the process. F is Faraday constant, and the value is equal to 96500 C per mole. And lastly, Q is the ratio between the activity concentration of product on the activity over concentration of the reactant, and the power will be coefficient. And now we will have an
How can we use it?
Wait, let me finish. Now, we will have an example. Calculate the potential cell for zinc and copper cell. When the zinc ion equal to 1 molar and the copper ion equal to 0.1 molar at 25 Celsius, we have two half reactions, one for copper and will be the cathode, and the other one for zinc will be the anode. Lastly, standard E for each one. We will use the Nernst equation to solve the problem. First, we should write the net reaction to find N. Then we will subtract the standard E for the cathode and the anode to find the E cell net. Since we have the concentrations for zinc and copper, it means we can calculate the Q. And we have the temperature, we will convert it from Celsius to Kelvin by adding 273. After we have all the values, we will use them in the equation and calculate it like this. And the answer will be, the unit is volt. That's how we calculate the potential cell.
But why do we use the Nernst equation?
Look like you were not focused enough with me. As I said in the story, to calculate the potential cell when the cell is not in the standard conditions. Is there any questions?
No.
Thank you for watching.
But